One thing I'd like to talk about a little bit is doing a lot with a little, and that means talking about CubeSats, which I think will be very important for the cislunar economy's development. The CubeSat revolution is approximately 20 years old, and a couple of professors in California, Bob Twiggs at Stanford and Jordi Puig-Suari at Cal Poly, are really the fathers of that CubeSat. And Bob kind of came up with the idea as a teaching model for engineering. Hey, you get a little Beanie Baby box at McDonald's, and he said, well, maybe if we built a small satellite, it would be inexpensive, it would be a good teaching device. All the engineering things that have to do with satellites could be done in that compact volume. And then to launch it without a risk to other payloads, the P-Pod launcher was developed by Jordi Puig-Suari, which is basically kind of a spring-loaded mechanism which would pop out these CubeSats out of a little track. They can be a cube 4 inches on a side or 10 centimeters on a side, and if you have one, that's called 1U. If you stick two of them together, that's a 2U CubeSat, and 3. So they're often 3U CubeSats, sometimes they're 6U. They're kind of a modular system, they're scalable, and this has really gone viral around the world. So many universities in many countries have found this to be a really good tool for encouraging students and innovation. But not only that, commercial companies and the military also say, well, we can do a lot with a much smaller investment, and microelectronics and advances in technology have taken something that started out as kind of, well, this is a teaching tool, and made it into a very mainstream kind of technology over the last 20 years. So most of these CubeSats get a ride from a larger mission. So there's probably a big satellite or two satellites on a large rocket that's still very expensive. It can carry a number of these smaller secondary CubeSat payloads and push them out. There's a spring-loaded. And so there are often several CubeSats. Now, the Indian Space Agency, I think, set a record recently where they had one of their rockets that launched over 100 CubeSats on one mission. It's turning a large rocket into a condominium, and the cost per CubeSat is still quite reasonable. This is an ongoing revolution. One aspect of that is saying, well, could we actually get a CubeSat to the moon? Most of these CubeSat are in low Earth orbit, and they're launched for, as a secondary payload, and they're kicked out, and they're in such a low orbit that that orbit decays, sometimes 6 months or a year, 2 years, sometimes a little bit longer. But that is a very economical way to put a satellite in orbit. So a lot of engineers have kind of cut their teeth on this CubeSat paradigm. More and more, this is a very serious mainstream tool. It's not just a training tool anymore. Back a number of years, there was a gentleman by the name of Russell Cox and a NASA colleague of his, Pamela Clark, at Goddard, who decided to look at the issue of trying to develop lunar CubeSats, which seemed kind of radical. Most of these CubeSats were in low Earth orbit to get something out to the moon. Wow, that seemed a stretch. But as people began to think about it and look at the potential and ideas developed, that was also welcomed by NASA, because these things were much less expensive than if we could do something real at the moon for just a fraction of the cost of maybe a Discovery mission is $200 million. Well, if a few $1 million would get something up to the moon that could do something useful, well, that would be terrific. So today, NASA has commissioned and funded development are several lunar CubeSats, and they will be riding along with the huge first mission 1 of the SLS Orion, and that will give them a boost to the moon. And there are several. One is called a lunar flashlight, and that will actually have an active laser that will shine down looking for ice, and there's an infrared spectrometer. The second one, which is called Lunar Ice Cube, has another infrared spectrometer, and that has to be cryo-cooled for the frequencies. Pamela Clark is indeed the science PI on that's coming out of Morehead State University. Lunar Flashlight is something that's coming out of Marshall, and I think Barbara Cohen is the PI on that one. And then there's another one coming out of Arizona State University. I think that's Lunar H-map, or hydrogen map. That's also an infrared spectrometer. And then there's a fourth, I think that's Lockheed, that's called Skyfire. So there are 4 of these lunar CubeSats that are going to be looking for confirming water ice and seeing if they can, from remote sensing data, have a better idea of how much ice is there and what might be operationally useful. Is there enough in a location that we could actually economically mine it? And if we can, then we could develop rocket fuel and life support. So there is a small flight of lunar cube satellites. In addition to those NASA CubeSats, they decided they would also put out a challenge, something called Lunar Quest. And the Lunar Quest program had to do with radio communications. They had 2 challenges. One is called a Deep Space Derby, and the challenge there was to go out 10 times the distance from the Earth to the Moon about 4 million kilometers, and send a CubeSat out and see if they could successfully transmit a reliable signal. So that's a radio communications, at that distance. The second challenge was called the Lunar Derby, and it was again a radio communications challenge to orbit the moon and be able to transmit reliably data from lunar orbit. There are 3 winners to that competition. One is the Cislunar Explorer by Cornell University. That happens to be an NSS-sponsored project, and Dean Larson is one of the members of our NSS organization that also has a constructive role, I think, in computer and software. There is a second winner. It's Earth Escape Explorer from the University of Colorado. The acronym there is CUE3. And there was a third winner, which is Team Miles, and the company is called Fluid and Reason, and they're out of Tampa, Florida. So there are 3 winners to that competition for a ride to the moon. Lunar Explorer also has a goal of producing fuel from water. They want to be able to hydrolyze the water into hydrogen and oxygen and use that as a propulsion mechanism. So in addition to meeting the radio communications challenges, that is another innovative technology that is part of that particular mission. So I'm glad that our NSS project and personnel are among those selected. So really, when you think of it, there's a small fleet of lunar cubes that are going along on Mission 1. They have some other payloads as well. Another entry there involved in NSS sponsorship, their objective was very different. They wanted to go and participate in both the Deep Space Derby and the Lunar Derby. But they decided that the way they would try and do it was quite unique. They wanted to get a ride to the International Space Station from one of the contractors in the commercial cargo program. And so we have SpaceX and we have ATK Orbital that both have contracts to service the International Space Station. So the CubeSat would get a ride and then would be transferred either through the space station or if it was an unpressurized area, through one of the robotic arms, and would be launched off the Kibo platform, which is one of the Japanese laboratory on the International Space Station. It seems almost incredulous that you could possibly launch something as small as a CubeSat from the International Space Station and get all the way 10 million kilometers from the Earth and then come back and then also orbit the moon. How would that be possible? Well, indeed, there are these unique orbits that are called low-energy trajectories. The company that is sponsoring this idea is XISP out of Cabin John, Maryland. So they started to investigate this, and they thought, boy, we can almost close the case. We can just close the case with no margin. And they went to Dr. Ed Belbruno, who is an expert in these low-energy trajectories, and he looked at their figures and refined them. He says, I believe that you can do that, and do that with a sufficient margin, that this is a credible idea. This is a small mass and small propulsion requirements and unique kinds of orbital mechanics that can be used. In that particular orbit, they would go out 10 million kilometers, and then the Earth's gravity would loop this around, and this could be designed to come back and then go into a ballistic capture orbit around the moon. But it's not a circular orbit, it's a very unusual orbit. It's an orbit that, if this is the moon, it would go up and orbit in elliptical loops. And it turns out that this is supposed to be a highly stable orbit. The lunar orbits, in circular, there are mass concentrations that make a regular orbit. It takes a lot of fuel to keeping it circular, otherwise it's going to crash. So in this particular case, here's an orbit that could be done with ballistic capture that's supposed to be stable, perhaps with very little station keeping, for 50 to 100 years. That's another unique aspect of this proposed mission. It shows you what kind of radical conclusions one might reach if you start looking at what can a CubeSat do. Another characteristic of that looping orbit is it comes very close to the lunar surface. It goes high, but it comes down to maybe as low as 50,000 feet. So that's just almost a little bit higher than a commercial aircraft. Certainly military aircraft and things like the U-2 would fly even above that on Earth. So the camera systems are actually very close to the lunar surface. So if you had a little camera on that lunar cube, there might be a possibility of getting some interesting high-resolution photographs from that distance. In those orbits, you would also be high enough that you would be able to communicate with the Earth. And because of the relatively low cost, to do the first one is a challenge. To demonstrate that this could actually be done, might be a $5 or $10 million projects, maybe somewhere in that category. But if done in a succession, maybe those costs would be done for like $1 million a piece. relative to so many other space missions, that's kind of chump change. And that would allow you perhaps to have a network of communication satellites that are lunar CubeSats, and that would allow you to cover the whole lunar globe with very stable orbits, and would allow you to receive signals from rovers or sortie missions or other things. And it might not be the main form of communication, but it certainly would be an insurance backup for different kinds of payloads. And NASA's main spacecraft would have an optical laser, but this would allow small satellites with radio communications to perform a backup service and a network service on the lunar surface. So there is the potential for using a network of such satellites to achieve some not only communications but maybe even navigation and positioning kinds of services. There could be a significant value, even though these are rather low-cost options. And there is yet another aspect to a mission like that. At present, there is no regime internationally that assigns orbits to the moon. There are a variety of different orbits. Some are circumpolar. You circle the poles of the North Pole or circle the South Pole. There are polar orbits, and of course it takes station keeping that, or maybe equatorial orbits. But there's some very unusual orbits. There are Lagrange orbits that are kind of looping, and so there are a variety of ways to position spacecraft near the moon for different purposes. That's a consideration that those may have, not only scientific value just for basic communications, but that could also be commercially very important. To get into that orbit and to be into a very valuable orbit would have a future commercial potential. At the present time, there's no regulatory restriction on the selection of a lunar orbit. So it's kind of a first come, first serve. So any country that sends up something to the moon can establish an orbit. And in the Earth, it's a little bit different. There's an international telecommunications, and they have regulatory authority over assigning slots for geostationary satellites. That authority hasn't been extended to the moon. It's not as regulated in cislunar space. A CubeSat might occupy an orbit near the moon that turns out to have very important commercial value. That could be of significance to a commercial communications company that wants to establish its presence in cislunar space around the moon. So Alpha CubeSat has a number of very interesting aspects to it that involve both potential scientific applications and innovative trajectory management, the launch from the space station, a fairly low price point. And I think that's an NSS project that I would like to be funded. Another aspect of innovation in CubeSats is the problem of space debris remediation. And so one of the questions is, are there innovative ideas that people can come with that will help something the size and cost of a CubeSat to do something real in space about cleaning up space debris? We have to clean up our mess. One organization that's a non-government organization at the United Nations is UNISEC Global, University Engineering Consortium. They have sponsored 2 competitions to address the issue of space debris remediation. And NSS very much applauds UNISEC Global and certainly would like to collaborate in any way that we constructively do to encourage universities, because space debris remediation is a high priority for action for the National Space Society. So that is an international program, and it's something that we feel that we should advocate and encourage. And if there are U.S. universities, or we can encourage interest and support for that, we certainly would like to be cheerleaders for UNISEC Global. Our goals are to work collaboratively with them to see what we could do to become involved in some ideas and to encourage wider participation in the United States. Another area of innovation at the CubeSat scale are the idea of having microbots and robots. These things would be very small. They might have a relatively short lifetime, but they might operate on the lunar surface and crawl around, and they might sample soil or take pictures or close up, or they might have a communications relay function. There could be a variety of different things. Things that insects that can do. An ant is not very impressive by itself if you look at how small it is, but you look at some of the ants build huge mounds, for example, in Africa. You'll see these huge constructions that ant colonies will make. So the collective power of a swarm, whether it's a beehive or an ant colony, we can do biomimetic kinds of things, looking at what might several or a swarm of these kind of microbots or satellites do. Many of these things would apply to Mars CubeSats. The idea that we could, for very similar energies, get things not only out to the moon, but to travel to Mars. We already have a communication network of Mars of large satellites, so even a little CubeSat can communicate and relay its message to a larger satellite, and that message could be relayed to the Earth. So we're just beginning to look at how these small but yet very significant, doing a lot with a little philosophy can affect the dual frontiers of the moon and Mars. And we're looking at a moon first path to Mars. The moon is closer, it's easiest for us to get there, but we're also almost in parallel thinking along the same lines as we extend these technologies and test them out at the moon to the challenges of exploring and settling Mars. Those are some of the things that I think are very exciting, and will help us develop the tools that we need to live and work in cislunar space between the Earth and the Moon and all the way down to the lunar surface and even farther beyond. When you think about what's happened as a result of the CubeSat revolution, it's to be that our satellites were extremely big and maybe the size of a school bus, and if you look at large communication satellites, they are very large. They could be $500 million or sometimes more. So when you think of how much we can do with such a small satellite today, it really is a revolution in doing a lot with a little. For what it cost to launch one satellite previously, we can now launch 100 CubeSats. That's a big improvement.